We completed this. We are done using a ruler construction. Oh, construction. Okay, we'll start with this construction. Yes, students, do you have geometry box with you all of you? Yeah, get geometry. Last concept left in construction. That is easier than locus, whatever we did. Not easy, similar to locus. Last part. I have three types: circumcircle, incircle. Okay, all of you remember 20A what we did? Two tangents, one simple tangent and two tangent students. And two tangent point is outside, left hand side and draw. Okay, two more concepts left, students, along with construction. This 120 degree, 60, 90, along with that angle bisector, perpendicular bisector. We just make use of triangle, angle bisector, perpendicular bisector. So first is circumcircle. Okay, circumcircle is in this circle or triangle. Okay, so circumcircle will pass through the vertices of this triangle, students. So basically outside, circumference or basically outside, it has to touch. The circumference should touch the outer boundary of the vertices. Okay, what is it? This is what you call circumcircle. And the center for this, we call circumcenter. Okay, for circumcircle, which is outside, we need two perpendicular bisectors. Two perpendicular bisectors. What do you mean by perpendicular bisector, students? You all know the symbol for perpendicular bisector? This is the symbol, right? Perpendicular. Yeah, what is this line? You can take it as A, B, C, and this is D. This CD will bisect this line into how many parts? Two parts. So how many perpendicular we need? How many perpendicular bisectors do we need? Two. You draw any triangle. Look here. We construct any triangle ABC. I mean, you construct a triangle ABC. In this triangle, you can take any two sides, students. For perpendicular bisector, they'll give you just one side value. They'll give it like this: AB. AB represents from A to point B. Your basic ray diagram in 6th standard you studied. So whenever they give AB, it is from just A to B. That is perpendicular bisector. Or they would just give you A to B like this. Angle bisector. For angle bisector, you'll have 2 points. First, circumcircle. You draw a triangle, whatever measurement they give, whether it is 60 degree, 135, 105. With all that, you draw a triangle and we use two perpendicular bisectors. Try to relate circumcircle with perpendicular bisector. Next, incircle. Incircle is inside the triangle. A circle inside the triangle. It will never touch the vertex. This is center. It should touch all three sides of the triangle ABC. And whatever inside we call incenter. Circumcircle, circumcenter, incircle, incenter. And we use two angle bisectors. Okay, you all have to relate this. Somehow try to relate perpendicular bisector with circumcircle. Perpendicular bisector. And next, angle bisector for incircle. Angle incircle. Okay, how will you all relate this? Where are the angles, students? Angles are on vertex or inside the triangle? Where are angles? So relate this. Angles are inside, so that comes for incircle. Is this clear? Now, a triangle ABC. Angle bisector is for incircle. Angle is inside, so incircle. The opposite is perpendicular bisector, circumcircle. You can take any two perpendicular bisectors. Let me take base BC. For perpendicular bisectors, you take more than half, cut an arc top and down like this. You get a line. Then I'll take AB, students. From A to B more than half. I'll construct and show you. From A to B more than half. Imagine you get a arc here and here. You get a line. This point, from this point to this. Can you see a line? This line, dark line. That will be the radius, students. You have to take that as radius and just construct it like this. Okay, let me show the construction. Right angle. So I'll take an equilateral triangle, 5 centimeters, all three sides, without any angle. First, let me construct without angle. Okay, all of you will concentrate. This is the important part. Angle bisector, perpendicular bisector, students. For perpendicular bisector, I'll use the red one, green. It should be more than half. See, I'm going to take the baseline. If this is half, and I'll tell you all the reason why. If you take half, you won't get the angle. Can you see? Is this half or less than half, students? All of you respond. Half or less than half? Less than half. See, if you take less than half, you get an arc here, and from A, is it touching this line? Is it touching that arc? No. That's the reason we take more than half, students. You're supposed to take more than half. Okay, now this is more than half. Only if you take more than half, two arcs will touch each other. Like this and bottom one. Next, from base, from vertex B. See, now this exactly coincides here. All of you will construct this, students. Draw a right angle. Equilateral. Take all five sides. All three sides are 6 centimeters. Be quick. Construct this. Take 6 centimeter. All three sides 6 centimeter. Equilateral triangle. Completed. Done. Next. Okay, Joanna, you're constructing, right? Cherisha, Joanna, Naomi, Lemula. Okay, write it as A, B, C, students. A, B, and C. Next, I took BC. Any question, always start from the base. base. Either you can take AB or AC, students. Same. Don't reduce the distance. This compass. Construct another angle bisector. I'll use the red one. Look here. Once I do, then you can try. Look, this is one line. B. Or take more than half. Just measure. Just check the line and take more than half. This is another line. Okay, construct this, students. Understood? All of you understood the way I've drawn? Yes. Draw A and B. From A to B, you'll get this line. You'll have three concepts: circumcircle, incircle, and hexagon. Even in ninth, you'll have that hexagon concept. Yes, students, completed? Join these two lines. Are we getting a center here? All of you got center O. That's center. From that, look, I'll mark the center. This, where the green line and the red line meets. This is the center O, students. Don't write it like this. Write it inside. Write O inside. Now, from this O, all of you respond. Complete it till here. Okay, from this center, take the measurement. This O to A, that is the radius. O to A will be radius. You keep here, can you see all three sides? Is it same? This is the center exact O, students. Draw a circle. From this center, you can measure B or A or C. Just measure A, keep that as radius. Draw a circle, that is in circumcircle. Circumcircle is done. Any doubts in this? What about locus? Even locus also we did same like this. Similar angle perpendicular. The only difference for locus we don't use this circumcircle, right? We didn't use circumcircle, incircle, student. And what's the one more point? What's the difference between circumcircle and locus concept? Look here. In circumcircle, draw hexagon and construct a circumcircle. Okay, 2013. Look at the third question. All of you, what is given, students? Construct ABC 3 measurement. Instead of this, we took 6 centimeters. Construct incircle. Okay, that is incircle. Where is circumcircle? All incircle questions are given. Fine. The difference between locus and incircle is they'll give you the names like this, student. Look here, hexagon, regular hexagon, circumscribing, circumscribe. Now, circumscribing meaning is circumcircle. What is required? Perpendicular bisector or angle bisector? For circumcircle, you need perpendicular bisector. Okay, perpendicular bisector. Draw a cyclic quadrilateral so that the 18. So look here, circumscribing question. Fine. In locus question, see, this is equidistant is given. Equidistant is equal distance from B and C. So what is required here? If they ask you to find equidistant B and C, students, what do you mean by equidistance B and D? B and C? See, D is equidistant. Equidistant. Can you all tell me the meaning of equidistant, students? Equi meaning is equal. Distant is distance. So if B and D are equal distance, if BD is 5 centimeter, what is DC? DC is also. So what kind of line is this? Angle or perpendicular? It is a perpendicular bisector. Take more than half and cut it. You'll get this line. That is what they have mentioned. Draw a cyclic quadrilateral so that D is equidistant. So don't get confused. This whenever equidistant is you'll have, that is basically a point which splits into two parts. Okay, now circumcircle is done, incircle, then regular hexagon. Whatever we constructed, we didn't use any angle. Okay, sometimes they give 120, 60, whatever angles. Concept is the same. Next, in center, incircle. For incircle, same students, draw three sides and we need to take angle bisector. Sometimes they might mention, if they don't mention, you can take any angle. You can start from, you can take these two angles. So just draw an arc from here like this. Then from this point, you'll get another arc. You have to connect it. So from that point, there is one more construction required. Okay, we'll start in center. Okay, all of you will construct same 6 degrees, student, 6 centimeters equilateral. Oh, this time we'll take 6, 7 and 8. Take 6 centimeter, construct. Then I'll take 7 centimeters. Right hand side, use 7 centimeters. For right hand side, use 7, all of you. Cut an arc. Base 6 centimeter, right hand side 7 centimeter. Done. Left hand side take 5 centimeters, students. Take 5 centimeters. Join these three lines. You should get a triangle like this. Scale in triangle. It's a scale in triangle. Completed, all of you are done. How many angle bisectors are required, students? Circle in center. In center we need inside. So it is angle bisector. How many angle bisectors I told you all? 2. Right? We need 2. Look here. Let us take B and C. From B, join this arc. Just draw an arc like this. All of you here. Same measurement from C. From C, same measurement. Just try. Draw an arc. Another arc here. It can be even bigger. You can take what 2, 3 centimeters. Measurement is not required. Arc. See, if you want, I'll extend. You can even draw arc like this. A bigger arc. Both the sides it should be same. If you draw bigger arc, both the sides you should have bigger one. After this, I will do one locus question, one or two locus question. You won't have confusion. Done. Completed till here. Then look at the point where every students look at this angle bisector. Now we are bisecting. We drew the angle. What are the two angles we have taken? B and T. I'll show even A. What if they ask A? Sometimes they'll mention. If they don't mention, you can take. Now angle is done. Bisector. Together angle bisect. Now we are going to bisect it. Bisect meaning at these 2 points. One point here, another point here. This way. So first angle bisector is done. Do the same. Second angle bisector. Same normal. Whatever we use for locus. Join these two lines. Use dotted line. Look, the blue line student, join these blue lines. Use dotted line. This point. Completed. Can you see we got a point in center? In center student. This point is known as I. I stands for in center, where two blue lines meet. Now, from that blue line, this line, look here, I'll draw this red one. It has to touch the base. Don't draw this students. Can you see this red line? All of you? I've touched it to the base. Response. Yeah. So this becomes a radius. From the center, it has to touch this base. I'll tell you how to draw this base. You shouldn't draw a straight line. This is just for example. Okay. If you construct like this, are we getting instant? I've gone wrong in the point. This line is wrong, students. The center is, you should get exact center. Exact. Okay, will do it using the normal method. Look, wherever the center is placed. Okay, wherever the center is placed, you need to cut an arc here. Can you see the base? I have to cut an arc here. Red line. Just cut an arc like this. Let me take it a bit bigger. Look, from the center, increase the protractor's compass size. Just cut an arc here. Look at this arc. It is too big. It has to just touch the baseline. From the center, cut an arc so that it touches only the baseline till here. Like this. Okay. Next, we need to bisect even this angle. Look at this angle. We need to bisect it. From this point, one arc. From this point, one. And from this point, here, one. Okay. We got this line. We need to connect this. Look. Wherever the point meets, from there till here, this line. Okay, this is the line, students. One more bisector, and that becomes a radius. Look, this becomes a radius from this point to here. This becomes a radius. We should get a circle, incircle. This with this radius, you'll get an incircle. Now slightly it's onto the right hand side. Let me do it again. Yeah, don't erase. What are the measurements, students? Can you tell me the measurement? What are the measurements we took? How much was the base? Was it 5 centimeter? Yes, all of them respond. Responded. You'll construct that whatever we had done. Base was centimeter, and right hand side it was 7, right? Right hand side. Left hand side 5. Then we need two angle bisectors. You can take these two angle bisectors. First one and second angle bisector. Now, because of these arrows, I'll take it small. Take it too small. Okay, we have a center, students. See this center where two arcs meet. Now from there, try to cut an arc which has to join. Just take few distance and cut a small arc like this, blue one. From the center, a small arc. This arc we draw to get a line. Okay, another perpendicular bisector, students, perpendicular. Then again from this arc, blue line, you have to cut top and down so that you get a perpendicular bisector on this. This. So the center should be proper. Yes, here. We have to join this blue line to this center. Look, this is our radius from the center to this line. See, this is our radius, students. Look where I have placed the compass. Is this clear till here? Do you understand? All the different points. Then we need to draw incircle. Hope I get it correctly. Yes, almost right. Almost touching, right? Can you respond? Left hand side there's a slight gap, students. Sir, because of this software, there's a slight gap. All of you will try this. You should get an incircle like this. Complete it. You'll want me to show the steps. First draw a triangle. After that, angle bisector is done. Angle bisector. Done. Next. From this center, can you see the center, Adya? From center, we need to cut an arc on this base line, student. So take, no, not same length. Little increase the length. Make sure it touches both the sides of the line, like this. If you take the same length, it won't touch, students. So it has to touch like this. I've increased the length. Only for two angle bisectors, length should be same. For two angle bisectors. Done. Did you get an arc like this, small arc in the bottom? Now wherever these 2 points, the line and the arc touches, keep your protractor, students. Compass there, keep your compass. Keep your compass at that point. And from there, construct angle bisector like this. This one. You should get a proper circle. If your construction is neat, you'll get a proper incircle. Then at this point, look where I've kept it. For circumcircle, the radius is very easy. Just draw two perpendicular bisector, you'll get the radius. For incircle, you need this line, a center which has to touch the base. Construct it like this. Let me know if you have done till here, till this part. Okay. The concept is same. Along with this, they might give angles. Next, all of you have done this. Join the line, students. Join this line. The center and this point. Make sure it is straight. Use your scale and draw this. Connect these 2 points. Naomi got it. Joanna, Cherisha. Who else online? Okay. Lemula, Mariana. Missing. Okay. Cherisha. Was Cherisha there in the beginning? Did she attend? Okay, fine. Now this becomes our radius, students. Can you see this center and the blue line which touches the base? Measure this, not measure. Keep your protractor like this, student. This becomes our radius. Look how I placed it. First place it like this. Done? All of you got this? Okay, place it like this. Okay, draw a circle, students. Keep this as radius. Compass, open your compass like this. Keep your radius and touch. Is it touching all three sides? Or is there any slight gap on the left hand side? Response, students. Is it touching there? What about others? Completed? Okay, look here. Left hand side, there is a slight gap because of this point, student. These points, I'm not able to identify the exact center. You should get. What about your diagram? Is it touching all three sides? Okay. So this is the diagram, students, in center. For in center, this blue line is the extra part, blue line. Look here, I'll show you all the calculation here, construction here. I'll tell you why we drew that blue line. Look here. This is a triangle like this. Draw an arc, small arc, so that this X mark doesn't come in the center. If not, you won't find the position, the center. See, a line, dotted line. Draw a dotted line. This is the center, student, center. From this center to this line is our radius. This is our center radius. But we don't know where the straight line goes. Even if you use your scale, sometimes you might go wrong. This is our radius. Okay. In order to draw this radius, from center O, increase the size of the compass. Distance, the angle distance, cut an arc like this. Cut a small arc. Okay. Then from this point P and Q, down two more arcs. You'll get a straight line, exact straight line, because we're not sure of this radius line, students. We are not sure of that black line, so never use a scale for that. Never use a scale and connect. Draw angle bisector. One more. Perpendicular bisectors. Two angle bisector, and from that center, one perpendicular. Then draw this line. Look here, connect it like this. Now this, the red line is the straight line. Only this part is required. Only the green one is required. That becomes a radius. Take that as radius. O as center. You'll get an circle like this. Okay, that is what we did here. And name whatever construction you do. Name A, B, C, centimeters. And we didn't take any angles. 60 degree, 90, nothing. So don't draw any angles. Okay, next one. Circumcircle done. Incircle done. Last, hexagon. You love, which one is that? Regular polygon in that hexagon question. Okay, hexagon has how many sides, students? Any doubts on those two? Whatever we did, Naomi, Lemula, Banner, nothing. Okay, Mariana, done. Hexagon, students. Hexa meaning is six-sided figure, like this. Hexagon is a six-sided figure. Each angle will be 120 degrees. Each angle should be 120. So basically we need to construct 120. Remember we did this last year? We used to turn the book and solve 120. Yeah, 120. All 120, students. In this 120, mostly you'll get only incircle concept. I mean circumcircle or incircle. A, B, C, D, E, F. 120. I'll show the calculation next. If I want a circumcircle on this, for circumcircle, what do we require, students? Two perpendicular bisector or angle bisector? Very good. Perpendicular bisector. Let me take any two sides. I'll take AB. Look, let me take AB and BC. Any two sides are fine. Okay, it shouldn't be opposite, students, next to each other. Take next to each other. You can take AB, BC or AB, AF. Now, AB take more than half, cut an arc top and down. From B, like this, cut an arc. Join this line. Extend it. Same goes with B and C. From B, cut an arc. From C, like this. Join. Extend this line. Check where they meet. They meet at a common point. This is not the exact point. They meet at a common point. Is this clear? All of you understood? Okay. From there, you can touch any one of the points. Total we have F 1, 2, 3, 4, 5, 6 alphabets. Okay, just a minute. 120. Okay, this center, I didn't get exact value. It should be somewhere down, students, down here. This is the center. Oh. From there, what are the radius? Can you tell me the radius? I mean, there are 6 vertices, students. Take any one vertex. Look at the blue line. Take this as radius. The distance, all the blue lines will be same. Look at this will be same. Take any value from O to A. Take O to A. That as radius. Keep it as radius. You'll get a circle on top like this. Okay. So a rough diagram I showed you how to draw. And one more thing, whenever they tell hexagon, just draw a 6-sided figure, student. Make sure you draw a rough diagram, simple rough diagram. Mark 120 degrees. Okay, what's the time? Fine. Take break. We'll continue at 11:40. After break, I'll show you hexagon concept construction. Yes, Mariana. See, circle is not. I'll tell you after break, Mariana. Okay. Yeah, take a short break. I'll just be back. Okay, all of you online. Shall we start hexagon construction? Fine. See, circumcircle, incircle, keep that as base and draw hexagon to it. It's the same. First construct hexagon. Is Mariana online? Mariana, this is not a rough diagram, Mariana. Left hand side, I showed you all the calculation. This is not rough diagram. For rough diagram, I thought you misunderstood. Okay, I'll show rough diagram. Rough diagram, you shouldn't draw like this and waste time, student. It should be small. If they give hexagon, remember construction, locus. Whatever locus questions we solve, everything had triangle in that, right? In locus question, everything had triangle. So working column, in working column or main column, just draw rough diagram. If a triangle is asked, draw triangle like this. Name it as ABC. Whatever centimeters give, if they 60 degree like this, and we know 90 degree would be like this. Not exactly, don't measure anything. If they give 120, just randomly draw a line like this. This is 120. These are for triangles. Okay. If they ask circumcircle, incircle, don't have to describe circumcircle. And don't waste your time drawing a circle, incircle, all those things. All these are wrong. All they need is just one basic triangle concept, triangle thing. Okay, they would give you like this: draw hexagon, 2.5, or let me take 3. They'll give less than 3 centimeter. Okay, 2.5, 3, 3.5, when decimal they would give. Hexagon is 6-sided figure. Just draw 6-sided figures like this, students. Then 3 centimeter. What are the information? Hexagon 3 centimeter. Name all the vertex A, B, C, D, E, F. What's each angle? I told you all. Each angle of hexagon is 120. Just show one value. Just show 1 or 2 values like this. 2 values. 120, 120. It is understood. All the sides are 3 centimeters. Right? 3, 3, 3 centimeters. Understood, Mariana? Rough diagram? So here it doesn't matter whether incircle, circumcircle. This is the rough diagram for hexagon. Okay. Main concept matters. Main concept is we are discussing about hexagon here. So they'll give you draw hexagon and draw circumcircle. Draw circumcircle. Or draw incircle. So it doesn't matter. Doesn't mean that you have to draw and circumcircle over here or encircle. No, so don't waste your time. This is the rough diagram. In board exam, what hardly they might give you a half mark for the students. Half. Even that is important. But still, if you don't draw, they might reduce that half mark. Okay, we'll start the construction 120 degrees. We'll start with the first question. First question. What is given here? Construct a regular hexagon. Look, hexagon question. Construct incircle. This is incircle question, third one. I'm just talking about board exam questions. 2010, 15, 13, 2018. ABCD, draw a circle circumscribing. Okay, next. 2008. What kind of question they have asked students? 2008. Construct a triangle and circumcircle. So, second question. A triangle. A circle which passes through center and mark. Okay, tell me this whether it is circumcircle or incircle, students. A circle which passes through the points. If it is passing through the points A, B, C, what is it? Do you think a incircle will touch A, B, C or a circumcircle? All of you will respond circumcircle. They didn't ask side, or they would say a circle which passes through sides, A, B, C, C, A. If it is touching the sides, this is incircle, students. This is incircle. A circle which touches sides A, B, C, C, A. Just look at the question, the way they said the question. Here, nowhere circumcircle is mentioned or incircle is mentioned. So you'll get these type of question. You have to understand the logic. I told you all, whichever touches the vertex, that is circumcircle. Then what kind of questions? Compass, again a triangle question. Triangle, here we need to draw 60 degrees. Point equidistance from, okay. This might be similar to locus, students. Still here it is a locus concept, locus. Below that, triangle. Okay, below that it is a normal. Whether it is circumcircle or incircle, we need to find out. 2017. All of you will answer. How do you solve this question? Eighth question. First we need to draw what? Response, students. First we need to draw triangle. What is angle A? How many degrees? So CAB. Yeah, 60 degrees. CAB. Construct the locus. Look here. It is a locus question till here. Even if locus is not given, there's nothing different, students. The meaning of locus is construction plus circumcircle. Sorry, angle bisector, perpendicular bisector. Only because of the word locus, students get confused. So this is nothing but normal triangle construction plus angle bisector, perpendicular bisector. Even if locus is not given, point equidistance AB, BC is given. When two arms are given, what is it? Angle bisector or perpendicular bisector? All of you respond. Angle bisector. What is common to AB and BC? A is common. From A, you will get an angle bisector. Next, from which one? From BA to BC. Is this clear? All of you understood? So whenever you draw angle bisector, circumcircle or incircle, where is angle bisector? Angle is inside the circle, so it should be a incircle. Hence, construct a circle touching all three sides. This is the only question which has both locus and construction. And there's nothing called locus, students. It is just basically triangle with perpendicular bisector, angle bisector. If you want, remember the keywords. And they'll make it very simple. They'll directly give locus. Even if they don't give, it is understood. Next, construct a circle touching three sides. When it is sides, what is it? Incircle, right? When it's touching the sides, it is incircle. And we also know that even if they don't give this, there's another word called internally. Internal is inside or outside? Meaning of internal. Internal is inside. External is outside. Even if this is not given, even if this three side is not given, fine. Here they have made it very simple question. And it was given 2017, almost 8-9 years back. Now if they make it complicated, imagine they don't give any of these. I've explained you the concept. Whenever we use angle bisector, it is always in circle. So they'll just tell construct a circle. What if they just tell construct a circle? You should be able to figure it out, whether it is incircle or circumcircle. Okay, I've explained all the concept, triangle, angles, each and every keyword, the difference between circumcircle, incircle, 2017. Then let us just go through the types of question they have given. If you understand, you can solve it later. See, all these are tough questions. Dates are not mentioned, students. Dates are not mentioned. Ignore. They won't give such type of question. If you want 11th question, we can construct. Look at 11th one, all of you. Using ruler and compass, construct PQR, 60-degree, draw a circumcircle. You can, if you want, 11th. If you have time, do the 11th one, 12th one. If not, just ignore. Not required. Isosceles type of questions, they don't give. And you all know what is isosceles, right? What do you mean by isosceles, students? Two sides are equal. Okay, if I have time, I'll teach isosceles equilateral construction. Mostly they don't ask that. Next, Incircle 15 and 16. If you want, you can try even 15 and 16. Dates are not mentioned. It is not board exam questions. Just for practice, draw Incircle question. Draw Incircle. 60 degrees given, 45 degrees given. Next, last three questions. Draw a regular hexagon. Regular hexagon. Circumcircle, incircle. And 2020, look at 2020 question. AB is 3 centimeter. It's a triangle question. Look, I'm highlighting all the keywords. Triangle, 90 degree. We need a triangle 90 degree. Right angle triangle. Circumscribing. Okay, if it is circumscribing, measure and write down the radius of the circle. Draw a right angle if it is circumscribing. Circumcircle. The meaning of circumscribing is circumcircle. We need circumcircle should be outside. For outside it is perpendicular bisectors, and we need two perpendicular bisectors. This is how quickly you have to think. When they give you a reading time, this is how you have to read, students. Triangle question. So just take 10-20 seconds to read the question. What is required? Construct it. Shall we start the construction? All of you understood all the concepts I've done. First question. Draw a regular hexagon of side how many centimeters? Side 4. Construct a circumcircle, students. Circumcircle. I'll show you all. 4 centimeters. Look here. 4 centimeter in the sense the base is 4 centimeter and right round 120 degrees. Use 120. Let me draw here. Okay. Start with left hand side or right hand side. Any point is fine. 120 degrees. Which side are we starting? Left or right? Which side is the students? Right hand side? Okay. If it is right hand side, I'm starting the arc at the right hand side. Like this. Day before yesterday, I mentioned a point. Wherever the line, if you have taken right hand side, left hand side, start with left hand side, this will become 60 degree. The first strike will be 60. From here, the second strike would be 120. Cut an arc. Done. Then go back to the question. 4 centimeters. Take 4 centimeters. Draw an arc. All of you will complete this hexagon, students. Start construction. Take 4 centimeters. Do it along with me. You'll get 2 questions. One locus, one construction. One mandatory question in section A. Mostly you might get circumcircle type. And one optional question, students. Optional question, locus question or normal, any construction question, hexagon question. 4 centimeters. Construct these two lines. Be quick. Let me know. After that, I'll show you 120 here. Be quick. If you have any doubts, go through the recording, students. Or if you have understood all the points, all the keywords, if you want only incircle, circumcircle construction, go through YouTube videos. Okay, just put how to draw circumcircle, how to draw incircle. Just watch one or two videos, circumcircle, incircle, hexagon. There they'll just teach you how to draw circumcircle, incircle, hexagon, but questions won't be there. Just learn the basics from YouTube. If you have any doubts, don't go through the recording. It is again 1.5 hours. You have to waste your time. Completed all of you all done? Shall we draw the next 120? Okay, 120 degrees. Fine, Adya. Others completed 120. Look at the students. Where the line and the arc touches, draw 120. This is 60. And from here, this is 120. Okay, from there 4 centimeters. Take 4 centimeters. Yes. Another 15 minutes, Maria. Now after hexagon, one question. One question is not enough. Okay, how many questions are here? Can you see? Four, not all four. I'll just teach you all. You can try one or two for homework. Wait, do you want to leave? 15 minutes. Be quick. It depends. If you'll complete quickly, we'll. This is circumcircle. I'm teaching circumcircle and incircle now. Then we'll do one locus and construction together. Okay, 4 centimeter. Then from there, for a straight line, you don't need 120 students. From top, we don't need 120. We know it is a straight line. Just draw 4 centimeter straight line. How many chapters are pending, Mariana? How many subjects are pending? You completed? Not important. Okay. What about tuition? Did sir complete it? Fine, Mariana. Then start with the previous years. Did he tell about previous year? All those things? Okay, fine. Complete it, Adya. Try this. 120. Look, only for the first three lines, 120 to 120 degrees are required, students. For the top one, you don't need 120. Just draw a straight line. Then turn your book. Turn your book, draw 120 here. All of you will complete 120. For me, it is not possible to construct. Draw, complete at least one figure, one diagram. Will end the class. Another 10, 15 minutes, 10 minutes. Be quick. When do you have science class, Mariana? 8 o'clock. Okay. See, we are already doing the previous year questions, students. Whatever we're solving are only previous year questions. Yes, students completed. Can you see we got 120? All of you. Minimum at least four constructions should be done. If not, you won't get a perfect value. See, these three are enough. These three things are enough. One, two, three, four, five. Yes. Only three constructions are enough. Just join this line. Fine. What about others? Completed 4 centimeter. Got the diagram like this, all of you all? Okay, fine, Evania. Yes, almost, yeah, 4 students. Measure, you're getting 4. Next. Which one shall we start? Okay, we'll start with circumcircle. For circumcircle, what is required? Angle bisector or perpendicular? All of you will respond. Yeah, perpendicular bisector. Let me take 2 points. Any two lines, students. A, B, C, D, E, F. Look at the red line. Let me take more than half. Look here. More than half. 2 perpendicular bisectors are required. One top and one line down. All of you construct 2 perpendicular bisectors. Be quick. One top and one down. Okay, you can take AB, BC students. Don't go with AF. Start AB, BC value. Next, join this line. Use a dotted line if possible. Use ruler and draw a dotted line. See, 10:40 all attend. 5 minutes for others to join. So usually 10:45 we start. 11:45, 12:15. 1.5 hour class. Or after 5-10 minutes I must extend. That's it. 1.5 hour morning, 1.5 hour evening. Done. Shall we draw one more? Perpendicular bisector B to C students. Use the same measurement. Don't change the measurement. Remember that. You won't get the value properly. Use the same measurement. Cut another arc, 2 arcs. Join these two lines. I'll use the green line. Connect these two. Extend it, student. Extend. These two arcs should touch. The red one and the green one should touch. Like this. All of you got this point? Okay, keep that center, students. Keep it as center. See, take this center O. Write it as O. O. Now A. You can take A, B, anything. Everything will be same. Look at A. Mine is slightly different. C is fine. B is also fine. Okay, F, it is slightly different, student. F is slightly inside. So if your construction is clear, you'll get the angle. So O to A, keep the value O to A, lock the compass and draw a circle, circumcircle. See, it is not touching at point F, students. Point F. You'll do the construction 120 degree, proper 120 degree. I'll tell you why I didn't get this 120. I'll show. You all will definitely get a proper diagram. All of you completed? Got this? And don't write 4 centimeter everywhere. It would look clumsy. It is understood hexagon is all the sides are equal 4. And write 120 here. Got it, Mariana, Joanna, Lemula, Naomi, Asha, others? Well, Stanisha. Oh, wait, Sharif. 1, 2, 3, 4, 5, 6. Okay, the reason I didn't get F is I didn't take a proper angle to it. The line is not straight here. If it was straight, this F would have touched the circumference. Fine. Another 5 minutes, I'll just quickly show you all incircle. You don't have to draw, do it later. Circumcircle, all are thorough with the circumcircle? Now Incircle students, I'll just continue with the same diagram. Look at Incircle. What are the things required for Incircle? Yes, respond. Angle bisector. So which angle shall we take? A and B? See, B already has angle bisector. Can you see there's already an arc, students, at B? There's arc, right? I'll do one thing. I'll use the same measurement for A as well. Look here. I'll use the same arc here. Look, the same arc I'll construct, same length, I'll construct another arc at A. Try it later. You can try it later like this. Now, angle bisector is from this point here, and from here it has to intersect like this. Next, same for B. This point and from here to here, 120 degrees. So at 60, it will exactly meet at 60. Draw two straight lines. Like this, and another line like this. Okay, angle bisector is slightly different, student. After this, you don't try to draw it directly. Keep this center, take this center, and from there you just draw an arc. Another arc should be here. Look at all of you. Till here, did you all understand angles? Two angle bisector, whatever I have drawn. Yes. From there, from that center, students, from that center, cut an arc like this. Look at the blue. I'll take green one. Yeah, look at the green one. A small arc. The reason is this arc, wherever the line touches, from there, from this point, another arc down to get a straight line. To get a straight line. Then from this point, another arc down like this. Join this line, this point to this point. Okay. After joining, now this becomes a radius. Look, we got a straight line. This becomes a radius, students. This one. Look at the compass where I have placed. Is this clear? All of you understood till here? Yeah, just basically to get a straight line. You can't use a ruler here. You have to show the calculation, this one, diagram part. If you just straightly do from ruler, they'll reduce marks. Okay, that's it. Now log this, just draw circle, Incircle. Fine. A bit it is out, students, here, not getting it properly. The reason, same, because of construction. But did you understand Incircle, all of you? Incircle is done. Okay, you all do it properly, you'll get a proper Incircle. See, mine here, AF side is fine, EF is fine. The other three sides, it's out. See, this side, it's come out. This side, it's come out. Okay, again, the concept is same. Only thing, because of the software, not able to get the exact values, so slightly it is popped out. Evening will continue. We'll continue with this and complete the construction. That's it. Yeah, if you want, try the second one for homework, students. After the class, just take 10 minutes time and do this. Hexagon 5 centimeter, draw circumscribing. This is circumscribing. Draw Incircle. See any Incircle question and complete it, students. Evening we'll do 2 questions. Fine, that's it for today. And evening at what time you'll have other class?